Everyone, we're going to look at some continuous random variable questions from past exams. So both of these are taken from exam 2 because you couldn't possibly do them without a calculator. And the reason they're chosen is because you have the continuous, but then you go into discrete. So we got to kind of think, okay, when does it stop becoming continuous, and when is it moving into discrete probability? All right, so let's have a look at the key things that kind of give it away. All right, so remember when we see a function, that's the key thing that tells us it's continuous. But anyway, let's read the question. So every year at Mathsland Secondary College, students hike to the top of the hill that rises behind the school. The time taken by a randomly selected student, so this is just a randomly selected student, so that'll be important later, to reach the top of the hill has the probability density function m with the rule. All right, very complicated. That's okay. We don't have to find the derivative of that, although it's not really that, oh no, maybe. All right, find the expected time. All right, so whenever we see expected, think of expected value, think of mean in minutes for a randomly selected student from Mathsland Secondary College to reach the top of the hill. So we have to give the expected time in minutes, and is it already in, T is given in minutes. All right, so we just got to make sure our units are the same. All right, give your answer to one decimal place. So it's worth 2 marks. So even though we can plug this straight onto our calculator, we do have to set up a definite integral to show that we know how to, what we've done. All right, 2 marks. We've got to show a little bit more than just an answer. So we're going to do the expected value. So remember your expected value, we're going from, so values of t is from 0. There's no upper limit there, so we're going to put infinity. And because it's the expected, we're going to multiply the function by x. And we don't have to rewrite it because it's already been defined. Oops, not x, silly, silly, silly. It is t. Ooh, don't make that mistake. If you put x, it's going to be wrong. All right, so t times m of t. All right, so our variable is t. All right, so that's all you need to do. And then we can just do it straight on the calculator. Oh, I hope you can't hear my son slowly having a coughing fit upstairs. All right, so whoops. Where is my definite integral? Come on, come on. All right, so we're going from 0. All right, I'm just going to have to flick it over because it's so annoying. All right, from come on, 0 to infinity. And big one to put in, so just take your time. 350, and it's extremely important that you do take your time because you're likely, where are my brackets? You're likely to come across questions that you'll be like, what? And so spend the time on the questions you can do. So making sure that you've got everything correct. Oh my God, this is such a long, complicated thing. Where's my E? God, I hope you can't hear my son. All right, t over 50, and I have been using t, but you can use x. You just got to make sure you don't have your answer in terms of t. That would be silly. All right, to the power of 3. All right, I'm just going to make sure I've put that all in correctly. So 3 over 50 times t over 50 to the power of 2 times e. Now, is that e? No, I don't think that says a power. E to the power, or is it? Kind of looks like it, doesn't it? Oh, we'll soon know as soon as I press enter. Oh, what am I doing? Oh, the mean. So, yeah, we've just proven that it is a probability density function. All right, so we've got to multiply it by t. Sorry, that was my bad. So you could put the t at the beginning. I just put it there, I don't know why. So 44.64, blah, blah, blah. We have to do it to one decimal place. So we just got to check for rounding. So 44.6 minutes. All right, and if you got that one, you probably would have realized, because we're, that would be 1 minute. Yeah, it would take 1 minute to run up the hill. All right, students who take 15 minutes to get to the top of the hill are regarded as elite. So less than 15 minutes, categorized as elite. Find the probability that a randomly selected student from Mathsland Secondary College is categorized as elite. So we're only doing 1 mark, so I don't have to actually show any notation there. We can just go straight onto our calculator. So this is where your calculator is great. Just highlight it and go down, and we're just going to change what we need. So I'm going to take that t out because we're not doing the expected value anymore. And our upper limit is 15 because remember, anyone below 15 is elite. All right, now this is the probability, so I don't need to change it, and we're doing it to 4 decimal places. So 0 to 66. All right, so that's all we need. Please make sure though, if you're using that probability later on, you need to use all of it. All right, so just highlight it, drag it down. All right, don't leave it to 4 decimal places. Use all the decimal places you have. All right, question G. So this is where we're coming into discrete. So I'll explain to you what is giving it away as being discrete. So the Year 12 students at Mathsland Secondary College make up the Year 12 students make up 1/7 of the total number of students at the school. So when you think about it, is there 7 year levels? No, there's 6. Anyway, of this Year 12 students at Mathsland Secondary College, 5% are categorized as elite. All right, so I'm starting to think you're either Year 12, not Year 12, elite, not elite. And in my head, I'm thinking, oh, this is going to be a great two-way table. And I love two-way tables because I think it just really sets everything out really well. All right, so we've got to find the probability that a randomly selected non-Year 12 student at Mathsland Secondary College is categorized as elite. All right, so basically we are looking for the probability that they're elite given that they're not in Year 12. So I might do E for elite, obviously, but T for Year 12, so T dash. So that's what we're looking for. And when you think about your conditional probability formula, we want the probability of elite and not Year 12 over the probability of not Year 12. All right, and you're like, well, how do I know what that is? All right, so let's do our two-way table. All right, so we've got, it doesn't matter which way you do it, so we've got elite, not elite, 12, Year 12, not Year 12. All right. Now, all our probabilities add to 1. Let's put some information in. So the Year 12 students make up 1/7. So we're going to have 1/7 over here. So that means 6/7 are not Year 12. All right, and then we know that 5% of the Year 12 students are categorized as elite. So that's not 5% of the total, it's 5% of the Year 12. So in this little spot here, we're going to have 0.05 times 1/7. All right, and I'm just going to leave it there because we'll just do that on our calculator. But if you're wanting to know what goes in that spot, so it's just 5% of the Year 12 students. So it can't be 5%. And if we did that, you will notice that your numbers don't work anyway. So it's just 5% of the Year 12 students. And then the proportion who are elite is from the previous question, so 0.0266. Now, and we'll use all those decimal places. All right, so if we look at our conditional probability formula, we do want the probability of E and not T, which is the number that's going to be in here. All right, so we'll work that out on our calculator in a second. And then the probability of not T is 6/7. So not that I really want to keep writing this, but I will. So 6/7, and the probability of E and not T. All right, so basically the whole column of E has to add to the 0.266. So if we can just subtract the 0.05 times 1/7, so 0.05 times 1/7, and we get 0.0194. All right, so we're just going to put that up the top there, so 0.0195. All right, we're going to do this all on the calculator anyway, so you don't really need to write all this. All right, so it's just this number, drag it down, divided by, and I'm just going to put it in brackets, 6/7, and that's our probability. So 0 and what was it? 4 decimal places, so 0.0227. Now, if we have a look at what could cause potential issues for this question, and this question was not answered well, I think because people are probably thinking, oh, how do I approach it? I always think if you've got to, let's put in quotation marks, events, like we do here, so year 12, not year 12, elite, not elite, do a two-way table. Now, what makes this two-way table a little bit tricky is this value that goes in here. Now, if you left it as 0.05, you would actually get a negative answer in here. And that's when you should think, okay, I've made a mistake. Let me just think about the question again. So you would read it. 5% of the year 12 students. It's not 5% of the total students. It's 5% of the year 12 students. So you have to do 0.05 times 1/7. All right, and you get 0.0227. And you'll notice when I did it on my calculator, we do all those decimal places. Very important. All right, let's have a look at another question. So here's coriander. I love coriander. So I know some people hate it, but I love it. All right, the height is measured in centimeters, and that's extremely important. Always note what the units of measurement are. All right, again, it tells me it's continuous because we've got a function there. State the mean height of the coriander plant. So this time it's only worth 1 mark. So I don't really need to show any working out. I can just plug it straight into my calculator and put the answer. All right, so we've got a definite integral. We're going from 0 to 50. And remember it's x times. So don't forget that like I did before. And then we've got pi over 100, and then sine, what are we, pi x over 50, and dx. And we don't have to restrict the domain. All right, it'll do it for us. And when you think about it, it's a sine graph, so it's highly likely, unless it was a composite function, it's highly likely going to be symmetrical, so that makes sense that it is 25. All right, so we can just put the answer there. All right, if we did have to show working out, just make sure you do it like we did with the previous question. So much work, so much space there, and it's worth 1 mark. All right, Patricia thinks that the smallest 15% of her coriander plants could be given a new type of plant food. Find the maximum height correct to the nearest millimeter. Ooh, tricky, tricky. So it's measured in centimeters. It's a bit unfair that they're changing the units. I kind of think if you wrote your answer in centimeters and you stated they were centimeters, that you shouldn't be marked incorrect, but that's my own opinion. All right, so find the maximum height correct to the nearest millimeter of a coriander plant if it is to be given the new plant food. So 15%. So remember, we're going to deal with not percentages, but proportions. So we've got to convert that to a decimal. Now, this one is worth 2 marks, so we've got to show a little bit of working out here. So we're going from 0 to some upper limit. It hasn't defined what that upper limit is, so we can just call it A. And we don't have to rewrite the function because it's been defined. We can just leave it as hx. So just be consistent. All right, always when you're working through these, be mindful of the variables being used. So the previous one, it was mt. So we've got to do it in terms of t. Here it's hx, which is great. All right, and that is equal to 0.15. So we're just converting the percentage to a decimal, and then you can just put that into your calculator. I can find my calculator. All right, so and I always forget to do solve. I go ahead and do my definite integral, and then I remember at the end to do solve. So it is solve from 0 to a, and I haven't got, oh yes I did it up here, silly me. Totally forgot, I just typed it in. All right, dx is everything correct before I press enter. No, I've got to solve for a. Now this might give us a general solution. Oops. Now what did I do wrong? It's always annoying. Did I not move my cursor? I don't think I made it equal 0.15 to be honest. Comma a. Alright, so we get a general solution. So at this point, because it's a trig function, just go back and restrict a. So I should have probably done that from the start. So we restrict a before we do the comma a, so just after your equation. So given that, and a is between 0 and 50, doesn't matter which inequality sign you use. All right, and there we go. So 12.659. So remember this answer is in centimeters. So it's 12.7 centimeters. Converting it to millimeters, just multiply it by 10. So it's 127 millimeters. All right, so not an overly difficult question, but I would hate to lose a mark just because I didn't put my answer in millimeters. That's stupid. Anyway, personal opinion. All right, now we get into the discrete parts. I'll explain what gives it away as being discrete. So Patricia also grows and sells tomato plants that she classifies as either tall or regular. She finds that 20% of her tomato plants are tall. All right, so 20% are tall. A customer, Jack, selects N tomato plants at random. All right, so this N kind of is giving me binomial vibes. So I kind of think, all right, let's just keep reading the question. So let Q be the probability that at least one, that's going to be important, of Jack's N tomato plants is tall. All right, so the regular part doesn't matter. That might come in later, I don't know. It's either going to be tall or not tall. All right, so it's going to be a success or a failure. If it's only one event, so here that event is being tall. All right, we don't need a two-way table because the regular part does not come into it. So you're either tall or you're not tall. All right, I guess here it's tall or regular, but we're just focusing on the tall. So you're either successfully tall or a failure at being tall if you're a tomato plant. So find the minimum value of N so that Q is greater than 0.95. So the issue I think with questions like this is we see a lot of letters being used and we're like, oh my God, what is Q, what is N, blah, blah, blah. So N is our number of trials. That's what we're looking for. So let's just say, all right, N, I don't know what it is. All right, that's what I'm going to be solving for. What else can I write that I'm pretty confident with? So we want the probability of at least one. All right, so we want the probability that X is greater than at least 1, so it's equal to. All right, so greater than or equal to 1 is Q. All right, so let Q be that probability. We don't know what that is. Now, we don't know what N is equal to, but we can basically say, well, probability that X is greater than or equal to 1 is the same as 1 minus the probability that X is equal to 0. And that's a common thing when you see discrete, especially with the binomial, and we'll get into the binomial part in a second. Although you probably don't need binomial for this. X is greater than or equal to 1. You just do the inverse, which is 1 minus what you don't want. All right, and that is still equal to Q. Now, the way the binomial comes in is 1 minus the probability that X is equal to 0. So I don't actually need to do this, but I'm going to set it up anyway, just to show you. So the probability that it's tall is 20%. All right, 0.2. So 0.2, oops, oh, I forgot one part. It's binomial, so it's n choose 0. Should put that in first. N choose 0 times probability of success, which is 0.2. Don't do it as a percentage. And that's to the power of 0. All right, so we don't want any of them tall. All right, so 0. And then the probability of success is 0.8, and that's to the power of n. All right, so hopefully you're familiar enough with your binomial distribution to set that up. And that is, so Q has to be greater than 0.95. So that's greater than, I probably should have done that before, 0.95. Now, you could type all that into your calculator, but you should know that n choose 0 is 1, and 0.2 to the power of 0 is also 1. So we're just left with 1 minus 0.8 to the power of n is greater than 0.95. So we can actually just solve for n. All right, so solve, and then 1 minus 0.8 to the power, to the power of n. You don't have to use n, you could use x if you wanted to, because it's sometimes a little bit easier to get to. And we can use our inequality sign, is greater than 0.95, comma, x. All right, so x, or in this case n, has to be greater than 13.4. So just make sure you write n is greater than 13.4. Now, if I round that down to 13, we're not going to get greater than 0.95, so I need to go one more. So the minimum value, so I can't leave it as an inequality, so the minimum value of n is 14. All right, we just leave it like that. Alrighty, see ya.